Hello, let's continue with our vector calculation and let's do our first exercise. Once we have considered all this notation for vector components and lengths, so let's sketch um, our vector represent by points represent by points let's say points A and coordinates for point A are 2 comma minus 3 comma 4 and a point B. The point B will be minus 2 comma 1 comma 1. So let's sketch that vector and then let's calculate components and find the length. Okay, so let's start first with the sketching. So let's find the point 2 comma minus 3 comma 4, and as we learned in the last lecture, let's move 2 units in the x-axis. So I have no scale here, but let's imagine that we have 2 units in the x-axis. Then in the negative y we move 3. So this is 1 2 3, let's say here, and move up 4 units in the z-axis. This 1 2 3 4. Okay, and let's name this point A with coordinates 2 comma minus 3 comma 4. Okay, so we have the first point. Let's go to the point B, and this point B is located at minus 2 in the z-axis. So this is minus 1 minus 2 somewhere here, and 1 in the y-axis, positive. So let's move 1 on the y-axis somewhere here, and we're going to move 1 unit in the z-axis, so we will move 1 unit in the z-axis. Okay, and this is our point B with coordinates minus 2 comma 1 comma 1. Okay, so this is the vector AB, and maybe we can represent that in this with this notation, and let's calculate the components. So let me draw a little line between these 2 points just to make this clear. Let's write a little line from here to here. So, and this is our vector AB, and now let's calculate the components. So the components for the vector, according to our formula, will be equal to minus 2 minus 2, which is this one minus this one, and 1 minus minus 3, which is this one minus this one, and 1 minus 4, which is this one minus this one. And this is the same as we did in this 2D vector. So the components is the amount of distance or the absolute distance between the z-axis, the y-axis, and the z-axis. In this case, if we do the operations here, we see that the components for vector AB is minus 4, 4, comma 3. And this is the components for the vector. Okay. Now, let's find the length. Okay. The length for vector AB remember that we need to put this vector AB between these two vertical lines to represent the modulus, or the length will be minus 4 square plus 4 square plus 3 square, and we will take the root square of this. So the length for this one equals 16 plus 16 plus 9, and this is equal to root square of 41. And this is something like, in approximation, something like 6.431. So the length for this vector from point A to point B is 6.4031, the square root of 41. And this is the components for this vector, and this is the sketch in the 3D coordinate system. So this is the way that we calculate in this the vector. So one more thing is to express this vector in the standard basis notation. So vector AB equals minus 4i plus 4j plus 3k. In some notebooks, you maybe will see a little hat between this on the top of these three letters. This is to identify that this is not a magnitude of any other kind, but it represents a vectorial notation. So if you write it like this or like this, will be okay. Just don't be confused if you see in some textbooks or reference that you see a little hat in the top of each one of these I, J, and K letters.